Okay. Good afternoon, everybody. This is Rudy Shankar with the Energy Systems Engineering at Lehigh University. And welcome to the seventh seminar in the series on AI. And this seventh seminar is titled Watts, Algorithms, and the Grid of Tomorrow. And this is a very appropriate subject because we've heard from regulators, we've heard from practitioners, and we'll be hearing from somebody who's right in between. The company Utility Analytics Institute has been in this business for many years, and I've had a good occasion of working with Gina 7, 8 years ago on predictive analytics, and her organization is very much in the center of things. So this will be a very exciting seminar, and I look forward to hearing Gina's talk. Let me introduce her background. Gina is the managing director of the UAI and the lead program strategist for T&D Worldwide, both part of the Endeavor Business Media. She works at the intersection of energy, data, and innovation, convening utility executives, engineers, and analysts to tackle the industry's most pressing challenges. Through UAI's annual events, peer communities, and growing membership platform, Gina has a direct line to how utilities across the country are adopting analytics and AI to modernize the grid, improve reliability, and navigate an increasingly complex energy future. So, Gina, the floor is yours.
Thanks so much, Rudy. Appreciate it. Okay, so let me start with, for the last century, the electric utility was one of the most stable industries in the world. The business model was pretty straightforward. The infrastructure was built to last decades, and the operating model really didn't change much from one generation of engineers to the next. So if you worked at a utility in 1970 and you came back in 1990, you'd almost recognize everything. Now, that started to change about 20 years ago when utilities started deploying smart meters at scale. For the first time, the utilities had two-way communication with nearly every customer endpoint, which sounds simple, but it was actually a fundamental shift. Suddenly, you weren't reading just a meter once a month. You had interval data, usage patterns, outage signals, tamper alerts. You had data that you had never had before. And honestly, most utilities weren't sure what to do with it, which is kind of where UAI came about. Then came sensor data on the grid itself. So on transformers, on lines, on substations, drones, cameras, SCADA upgrades. The data didn't just grow, it exploded. A utility that used to operate mostly on experience and intuition was now sitting on terabytes of signal that they didn't have tools or the workforce to really process. And now AI. So, what makes this moment different than the arrival of smart meters or sensors is that AI isn't just generating more data, it's finally giving the utilities a way of making sense of it all. So, predictive maintenance, regulatory automation, customer intelligence, grid simulation, the technology has finally caught up to the data problem that's been building in the utilities for 2 decades. So we'll get more into that today. So when I say the power industry is in the middle of the most significant transformation in over a century, I really mean that literally. Three waves of change: smart meters, sensors, and AI have hit in rapid succession in the utilities, and they're figuring out how to ride all three. It's going to look very different from the ones that don't figure that out. So I want to welcome y'all. My name is Gina Weber. As Rudy said, I'm the managing director of Utility Analytics Institute, or as we like to call it, UAI. Today, it's not going to be just a theoretical AI lecture. Everything you hear today is grounded on what real utilities are actually doing right now, real results and real stumbles that we've learned and heard from them over the past 2 years. So I want to thank Lehigh University and the Energy Systems Engineering Department for the invitation. A quick note, we'll have a dedicated Q&A at the end, but please drop questions in the chat as we go. I'll check that periodically and do my best at the end to answer as many as I can. Before we get into the industry, let me tell you a little bit more about who I am and why I have a front row seat to this story. I started my career as an intern in college. I was part of the industrial and large commercial accounts group at CenterPoint Energy based in Houston, Texas. This was my real first look at how a major investor owned utility thinks about complex customers. It was also at a time when deregulation in Texas was happening. So, an exciting time when utilities were kind of positioning themselves in a new way that they hadn't before. And then I joined CenterPoint Energy full time in 2010 as a business analyst. My first big project was building one of the early smart meter based programs to identify diversion and theft. So it was a fun project to figure out how people were stealing and how the meters told us the people that may be stealing power. So it was fascinating. One of the first things I saw was the flood of new data was coming in from meters. But we also had these other systems. I was trying to look at 5 screens at once and solve the challenge of what does that pattern look like and what is it telling us. And the business didn't always know what to do with the data that we found. And those are the problems that I still see in utilities today. From there, I had the opportunity to move into other roles. I got to be what I call as kind of a translator between the business and IT in our newly formed analytics organization. If you've ever been in a room where the data scientists are speaking one language and the operations team is speaking another, my job was to essentially bridge that. It's harder than it sounds. It's taught me a lot that technical capability is really only half the challenge. I then had the opportunity to move into grid operations and customer operations as a program manager and lead the organization forward as we became more data centric. So by the time I joined UAI, I had sat in enough utility chairs, business analyst, translator, program manager to understand really what it actually takes to move from data to decisions inside a complex regulated organization. And that's the lens that I want to bring here today and to everything that we do at UAI on a daily basis. So everything I'm going to show you today, the use cases, the barriers, the lessons, I've seen versions of them all from the inside. When a utility says our data quality isn't good enough for AI, I know exactly what that room looks like. When they say governance slowed them down, I've been there. That context is what I'm hoping to makes today useful. So let me tell you a little bit more about UAI to help you understand who we are and where we got this data for today's presentation. UAI is made up of members of utilities and solution providers. So it's primarily a utility community. All of our programming, the leadership, the content's built around what the utilities need, for utilities by utilities. But we also include solution providers as thought leaders. So we have community standards, a code of conduct that keep these conversations candid and non-commercial. Vendors who participate in UAI are there to share expertise, but not sell. And so that distinction is really important. UAI runs 9 peer communities. So each are focused on a specific domain that you see here, from things like grid analytics, customer analytics, to safety, to natural gas. These are ongoing monthly conversations that the utilities are having, not just one-time conferences. And then in 2024, we launched our newest community, the Gen AI community. It's currently the one exception to our typical membership model, where utilities asked to stand up the Gen AI community. They requested specifically that we not include solution providers initially. The reasoning was simple. They wanted a candid handle on what was actually happening with Gen AI inside utilities before outside perspectives shaped the conversation. So they were hearing, they had a ton of vendors coming at them with all of the latest and greatest shiny objects of AI, but they wanted to step away first and really figure out how governance was working, how they were going to apply AI governance within their utility, and talk about their strategy before they had outside voices. So think of UAI as kind of the living research community for utility analytics professionals. We're not a trade association. We're not a vendor consortium. It's a peer network of utilities and those thought leaders in the industry actually doing the work who want to talk with each other honestly. This is just to show you a representation of our members. This is probably some logos you identify with. These are some of our utility members to give you an idea of how many utilities. It ranges around 167 operating companies in North America primarily, but also a few international utilities. But as I mentioned, we also have solution provider members. And so these solution provider members are playing thought leader within these communities, sharing experiences and experience that they have with those utilities and being part of that conversation. Also, a big important role that they have is to listen to what the utilities are doing, what they need, challenges they're having. That's also very helpful for them to grow and advance as well. So what's driving all of this AI activity in the first place? Let's kind of set that stage. So electrification, this is a duality issue with AI. The grid wasn't designed for where we're headed. A new data center can add the load of the equivalent of a small city. Multiply that by hundreds of data center projects, millions of EVs, industrial electrification. You've got a really complex challenge that really requires AI to manage. Then you've got aging infrastructure. So a lot of the utility infrastructure that was built in the 60s or 70s, the engineering teams that built it are retiring. The documentation really lives in manuals and physical binders. You would walk into a cubicle and see dot matrix printing and manuals sitting on their desks, and that's how they were accessing that. So it's in physical binders or people's heads. And so AI is really starting to unlock all that institutional knowledge and apply predictive models to avoid failures before they happen. Data explosion, literally smart meters alone are generating billions, if not trillions of data points daily. Add sensors, drones, weather feeds, market signals. No human team can possibly process all of that. So the utilities that win are the ones that turn that data into decisions faster with the help of AI. Workforce, this one's underappreciated, but the utilities, it's one that we talk about often. I call it the great retirement, and utilities, that's a big problem. So AI tools that are able to capture how an expert technician thinks about a problem, how they process it, and they're like, oh, I've seen that before. I know exactly what's happening. And they're able to make that knowledge accessible to somebody maybe only 3 years into the career. It's a serious workforce multiplier. Regulatory, it's actually one of the first few use cases we saw being AI was applied to. If you've ever seen a rate case following, it is thousands of pages, and it can take weeks to months to put together. AI is cutting that work from weeks to months or even hours at some utilities. Board pressure, there's a lot of board pressure as ChatGPT put AI on the utility board agenda. It's actually been a gift to internal teams. They were really excited to have the pressure from the executives, the spotlight from the executives. Suddenly there was executive urgency and budget. So that budget became available. And so we'll talk a little bit more about that. But when the executives say we want AI, what was interesting is a lot of the utilities said we already have AI, but we're glad to have your support. And so we'll talk a little bit more into that as we get into it. So let me go back real quick and ask a question, and just you can drop this in chat or think about just something to think about. But if you had to guess, what do you think out of all of these driving factors, where do you think the most investment came from? What was driving the demand of these 6 factors? Just something for you to think about, because I have my thoughts just based on what I heard from utilities, but I do think that there's a couple that were more important driving factors that really drove the use of AI and utilities forward more than others. So let me show you what urgency actually produced. 2 years, this is 2 years of documented work inside utilities that we captured at UAI. So I'm going to kind of walk through this in a little bit more detail as we go. So in 2024, sessions were largely focused on how do we think about this? This is where they asked to keep the solution providers out, wanted some utility-only conversations, governance frameworks. Should we buy or build it? How do we educate our workforce on AI? How do we keep our data from leaking into public models? That privacy was a big concern. These were big questions, but the conversations were really strategic in nature. The shift from 2024 to 2025 was stark. By January 25, utilities were presenting deployed use cases, not pilots, production systems with metrics. The question changed from should we to here's what we've built and here's what happened. That acceleration is important context. The industry moved from strategy to production in roughly 12 to 18 months. That's really fast for a regulated industry. So utilities primarily consider themselves behind on analytics and digitalization. And so for them to go, in 12 to 18 months to are we going to use AI to here's how we're using it was really impressive. So some specific call outs here that I'll point out. February 2025, the session featured an audit team that cut report generation from 1 week to 1 minute using GPT-4o and Streamlit. In June 25, we had a session that covered RAG enhanced large language models, querying real asset documents. There were battery test reports, work orders, manuals in real time for field decisions. And then in July 2025, the session was titled "What Worked and What Didn't." And this is always a fun conversation, but the utilities will be really candid about failures they had, which is rare and very valuable. They love to learn about what worked, but even more important was what didn't, so they can learn from each other. You'll notice today I'm not going to name any utility specifically. That's intentional. The UAI community standard is the reason members are really willing to share with us failure stories along with successes, is that we keep that confidential. So a utility will tell you what went wrong if they know it stays in the room. And so I have to protect that. So that's the kind of information you'll get from their press releases. But today I'll just keep it generic and talk about the different use cases within utilities. So before I walk you through specific use cases, let me give you a map of where AI is touching the utility value chain. Utility's job is, as you know, is to take for electricity from where it's generated, whether it's at a coal plant, nuclear facility, a wind farm, solar panels, and move it through the transmission system down the distribution grid, ultimately to your home or business. Each step of that chain presents different engineering challenges and increasingly different AI approaches. So in generation, what we're seeing is this is really where a lot of the early AI use cases landed. Actually, back in 2022 and 2023, we started seeing the AI robots and robotics being used in generation facilities for safety. But it's where a lot of the most sensor data lives, and that the financial stakes of downtime are the highest in this place. So predictive maintenance on turbines, optimization of heat rates and gas plants, AI-assisted inspection of solar and wind assets, all of that was really critical in what drove the early use of AI in this segment. In transmission, the high voltage backbone, AI is being used here for fault detection, weather-driven outage modeling, and increasingly real-time grid simulation to advise operators. So this is where the AI is really starting to show up here. So closer to the customer and distribution, work order planning, transformer health monitoring, smart meter analytics. This is the massive AI opportunity that's still early, but they're getting more and more use cases in this area as we move forward. And then customer-facing AI is the most visible to us as consumers. Chatbots, voice agents, billing inquiries are all being used by utilities. But it also includes regulatory and compliance work that sits behind every customer interaction. So, you're very familiar with AI. I think now you even go to Taco Bell and order, and you've got an AI bot taking your order. The utilities are using that not just to talk to customers and help provide customers with information, but also being more efficient in regulatory and compliance work that they're having to do. So we're going to spend most of our time today talking about use cases happening across the value chain, and I'll be as specific as I can. So let's go into this use case kind of category by category and look at it. So first we'll get into grid operations and asset management. Predictive maintenance. This is one of the most mature AI use cases in the utilities, the one you have the most, you've probably read the most about. What changed with Gen AI is the ability to layer language understanding on top of sensor data. One utility built a system using RAG that can retrieve the actual text of asset manuals, previous work orders, and inspection reports alongside numerous sensor data. So instead of just getting an alert that a transformer is running hot, a technician can ask, what does the manual say about this failure mode, and what were the last 3 work orders on this unit in natural language in the field? We're no longer having to, teach how to ask AI a question or teach those prompting for the field agents, as they're able to use natural language in the field to retrieve information, not just on the manual, but also on the last specific work orders on that piece of equipment. Work order planning, this one surprised me. The bottleneck wasn't AI, it was the process. One utility spent months working side by side with plant planners to understand how they actually think through work order prep. The AI chatbot that they built reflects that logic. In this lesson, the best AI tools in utilities are the ones where domain experts help design them. And so that has been an important lesson that they've shared, is really keeping in design, when you're planning these out, to be very close to operations, to have them involved, was a really big lesson they learned in this use case. In nuclear, the ultimate stress test for AI governance, everything in nuclear operations is documented, it's highly regulated, and it's very safety critical. The utility that worked on this use case, the approach was to use Gen AI for information retrieval and document navigation. Not for decision making in this case. So a technician can ask, show me the affected document for this engineering change, and get a structured response instead of spending hours searching for that. The human is still making the call on what to do. So, and then on computer vision, kind of moving on to that one thing utilities have learned is you need a lot of labeled images to train a computer vision model. Most utilities don't have all of the images that they need to do this. So one of the clever solutions that's come up is they're using synthetic image generation, using AI to create these training images of defects they haven't actually been able to photograph yet. So it's a bootstrapping technique that's accelerating model development significantly. And so I'm excited to kind of see more of that as it's done. The nice thing about utilities as well is that because they are regulated and don't cross over, don't compete in most cases, at least on the transmission and distribution side, they're much more willing to share with each other these types of images to help them advance more quickly together. So let's talk about on the customer service side. The customer service use cases are the most visible to the public and often the first to get budget, because the return on investment story is really clear. So the first one, utilities are the AI-powered chatbots, the voice agents. The utilities deal with predictable, high-volume customer inquiries. So the outage status, when is my power coming back on? The billing questions, why is my bill so high? Can I make payment arrangements? New service requests, how do I get some power turned on? So AI is really good at handling those repetitive requests from customers. One utility automated 20 to 40% of help desk queries with a Copilot-based chatbot, and it saves nearly $1 million annually. So the key that it didn't replace the agents, it just handled the routine requests so that agents could focus on more complex requests more quickly. So training simulator, this one was interesting. One angle that they took here, think about how you train call center reps today. You have a trainer on the phone playing the role of an angry customer, and that's expensive, it's inconsistent. You might have a really angry trainer, or you might have one that's too nice of a trainer. And so the utilities replaced that trainer on the line with a large language model that plays the customer, and it has configurable personalities, it has different levels, and then it gives the customer service agent a scorecard afterwards. So training quality went up and the cost went down to train those agents. And then the most exciting one was a 3D avatar. So this was also really cool. I want to give you a glimpse of where the utilities are heading. One member built a customer-facing AI assistant using photorealistic 3D avatar. It looks and sounds just like a person. It listens to what you say, and it actually can execute transactions on the back end through robotics process automation. That's not just data. That's not just science fiction. So this is actually deployed in the utility today, and it represents a fundamental different model for how customers interact with their energy provider. Speech to text is the last one we'll talk about here on the customer side. So seemingly simple, it's been used for quite a long time, but a lineman in the field, in gloves in the rain, he can't type notes into the tablet. And so that voice to text that feeds structured data back into a work management system is a small AI application with real operational impact. So it's made some big changes for how information is getting back into our systems. So let's talk about another use case grouping, the document intelligence and regulatory AI. One of my favorite data points from 2 years in this UAI community, this Gen AI community, is an internal audit team at a utility was spending up to weeks generating first drafts of audit reports. They built a Gen AI application using GPT-4o and that tool, and a tool called Streamlit. If you've ever done any data science, you've probably heard or seen Streamlit. And now those drafts are generated in roughly 1 minute. So humans still are reviewing those, they're revising those, they're signing off on those, but the draft work is done for them. Regulatory filings, I worked with these people. It would take weeks to months to do these. So they're massive. The rate cases are really massive, expensive, and they're a burden for utilities. Every few years, a utility files a rate case with its state public utility commission, thousands of pages, big, giant documents on why they need that rate increase. So one utility used Azure OpenAI for this work and reported 90% accuracy on regulatory queries, 30% reduction in labor costs, and a 68% faster response time. So that's a fundamental change in how compliance work gets done for utilities. Okay. So let me make sure I'm covering all this. Oh, engineering standards. So I missed some here. So on engineering standards, this one is, let me make sure I'm here. Okay, I lost my spot in my notes. So this one probably resonates to all of you engineers. So imagine you're a field engineer, you need to know the construction standard for a specific type of pole installation. And in a traditional utility, you'd have to search through a document management system, navigate a bunch of PDFs, you maybe call somebody in engineering. With a Gen AI tool, one utility deployed, you can ask a question in plain English and get the answer with the document citation. So that may seem small, but multiply it across hundreds of engineers doing this a dozen times a week, it significantly increases their efficiency. Invoice validation is the last one that we'll talk about in this area. It's not glamorous, but it's really financially significant. Accounts payable and procurement are high volume, document heavy processes. And combining OCR and Gen AI for validation, it's catching errors, it's reducing manual review, accelerating payment cycles. So 1 minute from 1 week or even month in production, at a real utility, it's significant. So let's move to a developer productivity and internal enterprise tools. So got some data points for you here, but we'll get into code generation first. For those of you who are going to be writing code in your careers and in the energy systems engineering, I'm sure most of you will be. The productivity numbers from Gen AI coding tools are striking. Utilities are using tools like GitHub Copilot and are reporting 70 to 80% faster development in certain types of work. That's not everyone and not every task, but for code conversion, boilerplate, refactoring, it's consistent. One utility converted an entire legacy code base from its GUI-driven tool to Python in weeks instead of months. The honest question it raises is, if AI writes 70% of the code, what does the developer do? So the answer, based on what I'm seeing in utilities, is that they do the hard part, the architecture decisions, problem framing, testing strategy, knowing when AI is wrong. That skill premium is just moving up the stack. In private AI platforms, this was really important for utilities. One of the most consistent things I've heard across all of our 2 years of sessions in our Gen AI community, utilities do not want their data going into public models. They're very risk adverse and regulated, and they are acutely aware that if an employee pastes a customer record or operational data into a public ChatGPT session, that data could be used to train future models. And so the response has been to build private deployments on AWS, Azure, same language, large language model capabilities, but fully air gapped from public training. So it really now table stakes for any serious utility AI deployment. It's been a really important conversation, and a consistent theme across all of our conversations is how to make sure that these are private platforms. Microsoft is selling hard to utilities right now. Copilot is big. Copilot's embedded in tools we're already using. All of our employees are using Teams, Outlook, Word, Excel. The utility experience has been, productive is really happening, but it's the cost. So enterprise Copilot licenses are expensive. Several utilities are carefully segmenting who gets a full license versus a Teams-only license based on actual usage. Knowledge management, one utility did something smart. Instead of surveying employees about use cases, they analyzed the actual conversation logs from their internal AI tool. So they didn't ask them, are you going to use it or how are you using it? They actually looked at the logs to see what they were doing. It turned out that the queries were very different from what leadership predicted. They found 60 plus use cases they hadn't anticipated. The lesson: deploy first, then learn from usage. So what we've covered, these are some use cases. Now let's talk about what made them difficult. So this is a summary of kind of to help build some credibility and give you some numbers behind it. So I want to be honest about these numbers. These are real. These came directly from our utilities that they shared them in our community meetings. But they come with some context, and that matters. So the audit team, on the audit draft generation, that team went from a week to a minute. They had clean, structured audit data. If the underlying data was messy, the AI output would have been as well. So that clean data is really important, and it still remains to be a recurring theme. One of the challenges is getting executives to really buy into the importance of the governance and the work that goes into having clean, structured data. It's not as simple as just applying AI and using AI, as you've got to have that clean, structured data to use first. regulatory labor savings, the 33% labor savings didn't just come from deploying AI. It came from 6+ months of redesigning the regulatory filing process around AI. So understanding which steps could be automated and which couldn't were important. The help desk savings, the $1 million number required a 6-month pilot and significant change management, and then careful measurement. So if don't get this by you don't just get this by flipping a switch. It takes a lot of investment, change management to actually get these results. So the use cases are real and the return on investment is real. But the companies that are getting these results are really heavily invested on the data quality, on the process design, the governance, and then change management before they ever saw these results. And so AI may be 30% of the work. The rest is really the hard organizational stuff. Let's talk about one of the most important parts of this is the governance. And so this is a conversation that has been really important to utilities and a kind of theme throughout all of their conversations. So here's kind of what I've watched played out over 24 and 25. The utilities that invested the most in the governance frameworks in 24 were the ones moving the fastest in 25. So the governance wasn't slowing them down if they took a moment to pause and get it right. It was actually creating the trust that allowed production deployment to happen. But, and this is important, poorly designed governance did slow people down. So teams that engaged legal, audit, cybersecurity too late, or built tools without thinking through data classification had to stop and rebuild it. So the lesson isn't governance is good or governance is bad. It's do it right and do it early. AI governance committees. Almost every utility we heard from in 2024 stood up some version of a AI governance committee. This was different from their data governance committee. The ones that worked well were cross-functional. So they had people from multiple groups across their organization. They had legal, cybersecurity, internal audit, HR, and line of business representatives. The ones that struggled were either too small, it was just IT, or too large, 20+ people with no decision authority. Responsible AI policies. One utility required every employee to complete mandatory training and sign something that before they could use and access an internal Gen AI tool that they had taken this training and understood the importance of it. That sounds bureaucratic, they said, but it meant that when the system was deployed, the legal and audit teams had already signed off on all of that and understood that everybody was fully trained in that. So production happened faster because the governance was already done. Data classification. This one was fundamental for them. Is utilities had many classifications and categories of sensitive data, customer personally identifiable information, operational data that could be security risk, commercially sensitive information, HR data. But before you can build a private AI system, you need to know what data can go in and what data can't. And the utilities that had done this work in advance moved much faster than anybody else. So, and then the unstructured data, here's the one that surprised the team. The biggest source of AI failures in 24 and 25 for these utilities wasn't the model, it was the documents. Stale documents, duplicates of those, inconsistent formatted documents were the challenge. When a chatbot gave the wrong answer, it was really rooted in the bad source data. So they garbage in, garbage out. It's a common thing we hear a lot. AI just delivers more confidently when that data is cleaned up. So let's look at other blockers, the ones that weren't about governance. So some adoption barriers. One of the most valuable things here is the data quality. If there's one thing I want you to take from today, it's this, is that AI is not the hard part. It's the data is the hard part. And we've heard this consistently at UAI, just talking data and analytics on any analytics model. But I've heard this from utility to utility. It's a theme in nearly every conversation. The teams that are getting great results with Gen AI are the teams that spent years building good data practices before AI was even part of the conversation. The teams that are struggling are the ones that thought they could just skip that step. And it's usually pushed by the executives that didn't think that those steps were important. One utility described it perfectly. They said, our chatbot surfaces stale documents. The quality of its answers equals the quality of our document governance. That is exactly right. So it's really important that the data is clean and consistent. Governance timing. And I haven't even gotten to the slides. I may be jumping ahead. But the governance timing, this lesson came from multiple utilities, something we heard a few times. Engage the governance stakeholders early and make them partners in this process, not just gatekeepers. So the team that brought in legal and audit into the process at the design stage moved much faster than the teams that showed up at the end to ask for their approval. They were bought in, part of the process. They felt like they were the ones that helped create it. Change management, this one resonate with y'all, is I want to push back on something that's common for engineers and in y'all's culture, the idea that if you build a better tool, people will use it. In utilities, that's not always the case. Multiple organizations built AI tools with strong technical foundations and watched really the adoption struggle because they didn't invest in the training, the communications, and the cultural change. So the softer skills matter just as much as the engineering. And then build versus buy. This one was really important and actually a conversation a few times. The vendor landscape in 2024 was vastly different than what was in 2025 and even now in 2026. The tools that didn't exist 18 months ago are now at the table and are potentials. So utility have made rigid, build decisions in 2023, found themselves rebuilding from scratch now. So the lesson is build strong evaluation muscles, not permanent architecture commitments, is kind of the theme there. And there's been a lot of, it makes sense in certain cases to buy it or to utilize out of the box tools for certain circumstances. But in some cases, we need to buy or build a different tool. And so being flexible there and reviewing that really regularly with all the changes that are happening in AI is really important. All right. Let's go on to agentic AI. This one is really kind of where is this going? So most of what I described today is the AI that responds when you ask it something. You prompt it and it answers. This is different. The agent is a system that has a goal. It can perceive its environment. It can take actions. It can plan a sequence of steps to achieve that goal with minimal human direction in each step. So that shift sounds subtle, but implications are significant. Instead of a technician asking the AI, what does the manual say about failure modes? The system might detect the failure by itself, cross-reference the manual and check, parts inventory, identify the right technician, and draft the work order, submit it for approval, all without prompting anyone. And so it moves really to that business operations transformation. An example we heard was control room, grid control room. This was one of the most important kind of application I've seen discussed at UAI in this community. The grid operators are managing enormous complex systems, load balancing, renewable variability, demand response, interconnection. AI systems that run in real-time simulations can recommend to operators, not just replace them, but advise them which more um, like where they need more information, how to move faster, and are starting to appear. So the high stakes, this is really high stakes enough that the human stays firmly in the loop, but there's a cognitive load shift of helping make those decisions. Motor monitoring agent, this one was further along than people expected. The pattern is the sensor feeds a monitoring agent, and the agent detects anomaly patterns that precede failure. It creates a maintenance recommendation, checks parts availability, cues the work order with a human approving before anything happens in the physical world. The human person is remaining there as the decision maker, but AI is handling information, the information kind of assembly, putting that all together for them. Coordinated models. The architecture insight that's emerging here is don't just try to build one agent that does everything. Build specialized agents for work orders, for customer cases, and then use those general models as orchestrators that decide which specialists to engage. This is really kind of mirroring how organizations already work, is having those specialized agents. For engineering system engineers entering this field, the skill that will matter the most is understanding how to design systems that work safely with AI in the loop. So how do you build an appropriate human oversight? How to fail safely? Safety first is their number one goal. And how do you validate that an AI recommendation is trustworthy before acting on it? These are engineering design problems, and they're going to be central as we move forward. So what does this all mean for you specifically as energy leaders? So I want to be kind of honest with you, is because I think it will help to have the straight answer to questions in your career. Is context shift. You will not just enter a utility and have to convince anyone that AI matters. The conversation has already moved. People already know AI is important. The question now is whether you can be useful in it from day one, and that requires understanding it, not just being aware of it. Data quality. If I had to bet on one skill that will differentiate engineers over the next decade, it would be the ability to reason clearly about data quality. How do you tell executives and leaders, decision makers, that data quality, data pipelines, and data governance are significant in moving their organization forward with AI? AI amplifies the quality of your data, and so it doesn't just fix it. And so engineers who understand this will be invaluable. Governance. I know governance sounds like the boring part. Everybody at UAI, we hear it a lot, that's the one they have the hardest time selling to everybody. But here in reframing it and how they try to explain it is, it's a safety critical regulated industry, and the ability to design AI systems that are auditable, explainable, and compliant is an engineering differentiator. So it's not paperwork, it's design. Build versus buy. The specific tools you learn from today will be different in 5 years, probably different in 2 years. So the judgment about how to evaluate tools, how to build, how to versus buy, how to manage vendor relationships in a fast moving landscape, that judgment compounds over career. But regular review of that and being open-minded about the different tools out there and possibilities is really important. And then the most important engineering question over the next decade in utilities is, how do you design systems where AI acts in the world safely? And that's a control systems question. It's a human factors question. It's a reliability engineering question. So it's yours to help find the answer. The utilities that succeed in the next decade will be ones with people who can think clearly about both engineering and the organizational dimensions of AI. So that combination is rare and something they're trying to figure out. And so I hope some of you will be part of that. So let's get into, I have time for questions, but I have some conversation questions that may help start this. I see one question already in the chat. Alexander says, how is UAI looking for validating and checking what AI produces. What have you heard from your members on this topic and accuracy? So it's interesting as UAI isn't looking at it, but our members. So we're just kind of that collaboration organization that brings them together. But from our members, it's that validating and checking what they produce is a very much still a human managed process. So this is where they stress, just like we did to meter readers 10 to 20 years ago when smart meters were replacing them, they said, we're not going to have a job. Those meter readers now have jobs. They're just in different places. They're helping understand the data that comes in, validating the meter data that comes in. It's going to be very much like that on the AI side, is that the utilities are anticipating those people that have the jobs that this is helping make those decisions and pull all the data together. They're still there. Their just roles are different. And now they're validating that data very much in the pilots, but also when that AI model goes into production. So there's very much human oversight. Nothing's done without multiple, in most cases, multiple kind of human control points.
I have a question. Hi, my name is Selena. I'm part of the ESE program. I was wondering, since you mentioned the need for the quality of data and how utilities don't want to share their data and all that, in your opinion, what kinds of regulations need to be put in place for AI to be included into the utility as a baseline?
So it's a good question, and I want to step and say AI is such a big thing, from Gen AI to different types of AI tools, and it's such a big thing. I think part of it is there is a big need to educate not just our IT and engineers on AI, but everybody in the organization, from your customer service agents to your executives, and that AI training and understanding of what AI is and what it isn't, where it works and where it still needs human oversight, the importance of the different tools, when to use them, how to use them, when it's safe to use them, what information you can share with an AI tool, what you can't, is really important. And so I think the challenge here is that if we, there's one AI tool is not going to be the answer. Using ChatGPT for everything, or Claude for everything, or OpenAI, it's not going to be the answer. And so giving them a clear definition of what the tools are, when they should be used. But you have to do that organization wide. So it's a big change management process to ensure that everyone has those tools available, but also, making them aware of when those tools should and shouldn't be used and how they can be used safely and securely is important for the utilities.
Thank you.
Hope that answered your question.
Hi, my name is Bintusila. I'm also part of the ESE program. Thank you for your presentation. I have two questions. The first one is that you mentioned data readiness for AI. We know that it's one thing to want to include AI in your daily operation, but it's another thing to have your data ready to use AI. So what are some practical steps that the utility can do in this regard? And the next one is that in the nuclear sector, for example, they have international organization to share good practice. Is this something the utility are willing to do, or the market is too competitive to do that?
Okay, so I'm gonna get to the first one, and I may need to remind me of the second one. So what can they do to get their data ready? I'm not the expert. I can tell you what they're doing and the ones that are successful, some examples of what they're doing. So, and this comes really from not just the past 2 years of preparing for AI. This really comes from the past 20 years as they've gotten smart meter data, sensor data, these third-party data sources into their systems, is the ones that early on recognized that one, data is messy when it comes in, and if you have garbage in, you have garbage out. The ones that set up processes, checkpoints within that, management tools early on when they started receiving that data are the ones that are ready to start using AI more quickly. So the challenge is those that got all the data in didn't acknowledge the importance of that data readiness and then tried to jump in and in many cases were being pressured by executives to move forward with AI. And so I don't know like specific steps for you to take. It's every different data piece is different. But I think having a clear understanding and process to identify each of those data sources, understand those data from an initial kind of point when that data is being ingested, and making sure that data is clean before you decide to do anything with it, whether it's a Power BI tool, report, or whether it's using it in AI. It's got to be part of the early kind of ingestion process of data. As far as and remind me of your second question so I get it right.
The second question? Yeah. Oh, yeah. So I was mentioning that the nuclear sector, they have international organization to share good practice. Is it something that the utilities are willing to do regarding use of AI, or is it too competitive of a market to?
Actually, it's a great question. So, several of our members have nuclear organizations, and they've specifically come to us and said, "Hey, can you connect me with other utilities that are doing nuclear that we can get together and have a conversation?" They want to share and they want to talk. They have to be careful. It's a little bit different because there's some competition there. But in general, the utilities are willing and know that they can go farther together than they can by themselves. And so they are interested in sharing. And in fact, there's already collaboration with utilities doing their nuclear as it is. And I expect that to continue to expand as they get new use cases and find ways to advance their kind of space.
Thank you.
You're welcome.
Any more questions from the students? I want to open it up to the general audience now. Anybody has a question from the general audience? Please unmute yourself and introduce yourself.
So Alexander asked another question in chat, and I think it's a good one, is what do you see as the best training method for AI? I don't know that I have the answer for this. I think that ongoing regular conversations, whether it's part of monthly meetings, whether it's part of, community or not community organization announcements, that whether it's a newsletter or whether it's the intranet on their company. I think it's regular small bits of information on a regular basis for them, but as well as a singular place for them to go and learn and explore and access all of the different tools. I think it has to be regularly talked about. So, I'll tell a story back when early on in my career, when we were part of standing up an analytics organization, is executives weren't bought into analytics, and many people in the organization didn't know what analytics was. And so getting people to buy into analytics and understand what analytics is and what it could do for our organization, we had this challenge. And my old boss came up with a fun solution. It was a time during an election at the time, years ago, and he created a badge that said, "I support analytics," just like you would like a political politician's button or sticker. And everybody he would talk to that was using analytics, that he told about analytics, that was building it out, he would hand out these badges. So he'd keep these badges in his pocket and he'd hand them out, and we would hand them out in meetings when we'd talk to businesses about what we were doing. And so by, within a couple months, everybody was walking around the company in the "I support analytics" badge. And so it drove interest in analytics. And I think the same thing can be done for AI. People want AI, so there's that. You don't have to overcome that hurdle of that, but understanding what it is, building kind of a campaign about it where they're seeing it on a regular basis, it's part of their everyday conversation. I think it's going to be your best way to get people to buy in and understand the importance of it. And then it will drive, hopefully, their interest in the training. I think you're still going to have to do, online basic training of here's when to use AI and here's how to use it safely. But those regular conversations in small chunks is going to be very helpful.
Questions for Gina?
I either bored you all or I answered all the questions.
Good.
All of this information came from a report we did, and I can also share that report with y'all. I'll pass that on to Rudy to share, but it's out on the utilityanalytics.com website as well.
So Gina, I have a question. The training data and then trying to predict with it has a long history, and the limitations, of course, was because you didn't have computing power. Right now you have the computing power, and so there's tons of data you can throw at it. But as you said before, if you're not careful about the type of data you're feeding, just garbage in, garbage out. So is that still very strong? Is that one of the reasons why utilities may not adopt this very quickly?
I think that, part of it is that. Part of it is they're just, and this is historically too, they're very cautious, right? They're regulated. Safety first is their motto in nearly all cases. And so they just are cautious about how to proceed, especially with the risk of cybersecurity threats. And so I don't think it's, are we going to use AI? Every tool they're buying these days or already have is now, has some kind of out of the box AI agent to it or solution to it. The question is when is it appropriate to use? How do we use it? And when is it safe and in what cases can it be used and what should we be leaving out or not including? And so I think those are the decisions they're having to make. For sure, they recognize, or it's more visible now that garbage in, garbage out is a situation. I don't think it was as obvious before, and more, examples of that are coming to light. But I also don't think I think they may have underestimated how much data is needed for a training model. So, that's something else that's coming to light is, like the number of images that they need to train for, that they need from these drones or to train on asset management may have been underestimated, and they're, having to figure that out now.
Questions for Gina? So Gina, while we're waiting for another question, my thought is, are there utilities, you don't have to name them, that have used this AI technology to reflect on their bottom line, where it could be attractive as a stock, that people could buy? I mean, is there anybody that close?
They're not telling that story if there is. I bet there is, Rudy. I haven't seen that use case presented yet. But it would shock me if it hadn't been, at least in pilot, applied to that use case to see, bottom line, how is their, industry or their organization performing, or where are they at compared to others. But that story hasn't been told yet. Okay. To be continued.
Yeah, good. Questions for Gina?
All right. How big of an economic cost impact is everything related to AI? How expensive is this tool? That is something I am unqualified to answer. I can say, when you say how expensive is this tool, this is not a single tool. This is thousands of tools. So every system they have, their meter data management, their SCADA data system, their customer information system, all of their systems, in most cases these days, have some form of AI tool set that is available to use within that system. Some have chosen to use those built-in systems, some have chosen not to or build their own to support those systems. And then, there's other tools like Copilot and Claude or ChatGPT. There's so many different AI tools, Microsoft Azure, AWS. There's so many different AI tools. They can get very pricey. Utilities in general, I mean, we saw it even back with meters and meter data management systems. Is utilities love to build their own systems. They know what's being built for them. It's designed for them. Every utility system is designed a little bit differently, different types of meters, different data coming in. And so when they have the opportunity to build it, they feel like they have some say in that it fits them and it's not them trying to fit square peg round hole. The challenge with the build situation is that things are escalating and changing so quickly that can they keep up? So there's a cost to building it, is they may turn around in 12 months, 6 months and have to rebuild it again. And so they're evaluating that question regularly, and they may go one direction today and say, we're going to build it because we know our data, we know our system. But in 6 months from now, there may be a tool that has advanced much more quickly at a more cost-effective way. I have no way of telling you how expensive a tool or how much it's affecting our economy, but it's great. The challenge with the utilities is that not only are they wanting to use, there's kind of a duality situation here, is not only are they wanting to use AI and using it, for all these different kind of examples and use cases I showed you today, but the challenge is also supporting AI, right? Is they're having to power these data centers that are supporting AI. And so not only are utilities using and helping drive the use of AI, they're trying to figure out how to update their grid and get enough generation and support an infrastructure to support these data centers that are doing it. So there's two focuses in the utility: is let's use AI, but we also got to build our grid out to support these. And it's a growth that they have never seen before and really going to have a big impact on the industry in the next 5 to 10 years.
Well, I was just saw the questions that you suggested we discuss on our Zoom chat. How about the question for number 5? How should ESE programs like ours evolve the curriculum? This is moving so fast. The curriculum obviously, it lags a little bit behind. What would you recommend, Gina?
Oh, I gotta answer my own question. I made it hard on myself. I think it's a lot of listening. I think understanding the use cases from utilities and hearing what those latest pilots are and what those latest use cases is really valuable in seeing how AI is advancing within the utility space. I think the other thing is listening to the solution providers. So there's a lot of value in understanding all of there's not all, there's hundreds if not thousands of AI solution providers, but if you can listen to some of those big players in the industry and understand how their product is evolving, look at their roadmaps for growth and what their expectations is, I think is a big piece there. Unfortunately, Rudy, it's not going to be able to be printed in a textbook anymore and used for 3 to 5 years. 3 to 5 years from now, that textbook will be outdated.
Exactly right.
So, it's probably every semester or every school year, you're having to go and look at the latest use cases and how much it's changing. I never anticipated, the quick change, that 12 to 18 months turnaround that we've seen from just talking strategy to these use cases now are in full production within utilities. That's a quick use case. It took us 10 years 5 to 10 years to deploy smart meters in some major areas. So to be able to implement in full production some of these use cases is pretty significant.
And
What
there's a Tom has got a question. Can you see
How
that,
are
Gina?
AI is being deployed in utilities? Generally, the deployment of hardware is prohibited for most utilities to build AI data centers for themselves. If the private AI is deployed within the vendor's hardware, what guarantees are there that data stays private? We see this all the time with people's health data or online data has been compromised and leaked or grabbed. So, how are utilities generally deploying AI? Great question, and it's one that I think has been an ongoing conversation. So, there's been a conversation from the get-go for utilities. Is it in the cloud or on-prem, and how to manage that? They have their own cloud environments, or they have been assured by um, Microsoft or AWS, that those clouds are secure for them. I don't know the back end of how they are being assured of that. I will tell you what I have observed and listened and kind of talked about is that utilities 5 years ago, they were still trying to figure out how to utilize the cloud environment. They couldn't, it was all the cost of the cloud was all coming out of O&M, and there was a strong challenge in how to fund the cloud environment. And I will say that discussion is less common these days, and more utilities are utilizing the cloud, and have found ways to financially make that viable, as well as I think they feel comfortable with the cybersecurity opportunity, or work that's being done to help secure that for them. So I don't know that specifically, but they've come a long way in the past 5 years in those cloud environments and feeling comfortable about the cybersecurity that's going along with those.
Questions for Gina? You got a few minutes here.
I will do a plug. Let me plug my event real quick. If y'all ever have the chance, and I'll share this, we have an event once a year. It's being hosted by SRP this year in Glendale. So if y'all have the chance to come out to Glendale, UA Week, Rudy has spoken at our events before, but our event is a fun one. We do offer special rates for university students. We'd love for y'all to come and learn with us if you have the chance to come out to Glendale. That's October 20th through 22nd this fall. So we're programming that right now and picking all of the speakers and sessions and topics. AI and data centers is a big part of that. So, explore more. The program will be posted and all the content will be posted by June 1st. So look for that. I'll leave that at that.
Yes, and I tell you, if you get a chance, you should go to the UA week because it's really very exciting. Last time I was there, I really enjoyed it. Well, thank you again, Gina, and I know that you guys are took a bit of your time from what you usually do. I know you guys are very busy, and thank you again for this presentation. And we look forward to getting here for the next batch of students.
Yeah, absolutely. Thanks for letting me be part of it. I appreciate the time. And I'll share this presentation with you, Rudy, for you to share.
Okay.
We got another question. The federal government operates many electric utility systems from internal systems, Department of Defense. Do you ever see federal involvement in your groups? Not specifically. I mean, we do have WAPA. We like TVA is a member. We have MISO and CERC and a few of the regulated kind of oversight committees. So not specifically the government, but there are some government entities or utilities that are part of our membership and part of these conversations, and they're in the same path and doing the same things as any of our other members. So
Well, thank you all, and our last lecture in the series is 2 weeks from now, or 3 weeks from now, I forget. Well, that will be kind of it wraps up the theme of this seminar series. It'll talk about the legal and policy issues that could impede or could advance, AI applications in power industry. And I look forward to seeing all of you in our next presentation and the last presentation was the spring. But again, Gina, thank you again. I think your presentation was kind of brought all the others, like a reality check, where it means, rubber meets the road, as it were. Thank you.
Yeah. It's fun. It's fun to watch and fun to hear and be part of those conversations for sure. So it's an exciting time over in the utilities. Lots going on.
Yeah. Thank you all.
All right. Y'all have a good afternoon. Thanks for inviting me.
Bye-bye.
Yeah.
Bye.
Thank you.
Thank you.